Good morning, students. Myself, Deepa Deshnur, and this is our physics class. Today, we shall start the topic optics. Optics is the study of properties of light and interaction of light with matter, how the light travels, how it interacts with matter, and how it propagates. So, collectively, the study of all these things is called as optics. Now, optics is categorized mainly into three branches. Those are: first one is ray optics or geometrical optics, second one is wave optics or physical optics, and the third one is quantum optics. Ray optics is today's topic of interest. Now, it is the branch of optics which deals with the properties of light by assuming light as a ray. Now, what is a ray? When a light travels from one point to another point, from point A to B, when light travels from one point to another point, it follows a straight line path. And this property of light is called as rectilinear propagation. Traveling along a straight line is called as rectilinear propagation of light. Now, when it is traveling from one point to another point, the path followed by the light along a straight line is called as ray of light. Now, the bundle of such a ray of light is called as beam of light. The bundle of such rays of light is called as beam of light. Now, in this topic, we frequently come across the terms object and image. Now, what is object? Object is a source from which light rays are emitted, and image is a point of convergence or apparent point of divergence, or in general you can say image is the replica of the object. Reflection and refraction are the phenomena which can be explained by assuming light as a ray. Reflection in general you can say as a bouncing back. For example, if you throw a ball to a wall, it bounces back in the same medium or same side in the similar way. When light hits any surface, it comes back into the same medium. So this process is called as reflection of light. So you can define it as the phenomenon of returning of light in the same medium when it falls on any surface is known as a reflection of light. Now we'll see some terms related to a reflection of light. For that, consider a reflecting surface. Now, a ray of light AO is incident on that reflecting surface. So here is the point of incidence where the ray AO is in contact with the surface. When the ray AO hits the surface, it bounces back, and that is called as reflected ray. OB is the reflected ray. At the point of incidence, O is called as point of incidence. At the point of incidence, we can draw a perpendicular to the surface. We can draw a perpendicular line to the surface. Where that perpendicular line has to be drawn? At the point of incidence. Now that perpendicular line is called as normal to the surface. So in this reflection process, AO is the incident ray, OB is the reflected ray, and NO is called as normal to the surface. Now the angle between incident ray and normal to the surface, nothing but between AO and NO, is termed as angle of incidence. angle between incident ray and normal to the surface is termed as angle of incidence, which is denoted by a letter small letter I. Now, the angle between reflected ray OB and normal to the surface NO is termed as angle of reflection. How we measure the angle of incidence and angle of reflection? These are between the angle between incident ray and normal to the surface is called as angle of incidence. Angle between reflected ray and normal to the surface is called as angle of reflection. There are two laws of reflection. The first one is angle of incidence is equal to the angle of reflection is nothing but angle I is equal to angle R. The second law is the incident ray, reflected ray and normal to the surface. All these three lie in the same plane. It means AO, NO and BO. Referring to this diagram, we can say AO, NO and BO. All these three lie in the same plane. Here you can note that these two laws of reflection are valid on any reflecting surface. These laws are valid for any reflecting surface, whether the reflecting surface is plane or a curved one. Reflecting surface is nothing but a mirror. So these laws are valid for a plane mirror or curved mirror, also valid for curved mirror. Now the question comes, what is a curved mirror? Now we'll see some important terms related to curved mirror, how these curved mirrors are formed and some important terms related to it. These curved mirrors are also called as spherical mirrors or spherical surfaces. Why it is called as spherical? Because they are taken from a sphere. They are a part of a sphere. To understand this, consider a hollow sphere. Consider a hollow sphere made up of glass. The example that you can imagine is a football made up of a glass. Football is a hollow and you have to assume it is made up of a glass. So you are considering a hollow glass sphere. You can refer to the first diagram. Where we have taken a hollow glass sphere. It is a two-dimensional diagram. Okay. Now, in that hollow glass sphere, you have to cut that sphere by side. And you have to take that small cut portion from that sphere. You have to take out that small portion. You can refer to the second diagram. You are going to get the similar structure. When you take that small portion, cut portion out of the sphere, you can get a structure similar to the second diagram. It is similar to a watch glass. You can compare that small portion that you have taken out to the watch glass. A spherical surface, which is nothing but the part of a sphere. Now that watch glass is transparent. Now if you paint that watch glass on any side, either inside or inner side or outer side, it starts reflecting. Now it becomes a mirror. As it is a part of a sphere, it becomes spherical mirror or a curved reflecting surfaces. So you have an idea that how these spherical mirrors are formed. You have taken a hollow glass sphere, you have cut that glass sphere by side, you are going to get a structure similar to the watch glass, and when you paint it on any side, it is going to reflect and becomes a spherical mirror. Now we'll see some important terms related to the spherical mirror. Among those, the first one is aperture. It is the area of the mirror available for interaction of light. It is the area available for the interaction of light. So the surface area of the watch glass, the surface area of the watch glass, you can call it as aperture. The second point is pole. Pole is the midpoint of the spherical mirror, or else you can say it is the geometrical center of the mirror. The geometrical center of the mirror. You can consider an example of an open umbrella. If you take an open umbrella, the center of the open umbrella where the holding stick is attached, the center of the open umbrella where the holding stick is attached, that point you can compare to the pole of the mirror. You can compare to the pole of the mirror. So pole is nothing but the geometrical center of the spherical mirror. The third point is center of curvature. For pole of the mirror, you can refer to the third diagram. The dot you can see in the third diagram is nothing but pole of the mirror. The third point is center of curvature. Again, you have to refer for the first diagram. The center of the sphere of which the spherical mirror is a part. Now, before taking out that spherical surface, it was a part of a mirror. So the center of that sphere whose part is our spherical surface is called as center of curvature of the spherical mirror. Fourth one is radius of curvature. Radius of curvature of the spherical surface is the radius of the sphere of which the spherical mirror is a part. So this is the radius of curvature of the spherical surface. It is the radius of a sphere whose part is our reflecting surface, whose part is our spherical reflecting surface. Or in a simple way, you can define it as it is the distance between the pole, it is the distance between the pole and center of curvature. Radius of curvature is, it can also be defined as the distance between the pole and the center of curvature. The fifth point is principal axis. The line joining the pole and the center of curvature is known as principal axis. So the line from P to R and its continuation part. So this is the line joining PR. Line joining the pole and the center of curvature is, PC is known as principal axis. Now this principal axis is always perpendicular to the mirror, Now we'll move on to the types of the mirror. So referring to the second diagram, what we have stated, when you take that cut portion from the sphere out, it is something similar to the watch glass. Now when we paint either inner side of the watch glass or outer side of the watch glass, it starts reflecting. Now the question comes, which side of the watch glass has to be painted? Depending upon that, the mirror can be classified. So here we are taking the parts of the spherical surface, or you can say a side view of a watch glass. In the first one, we are painting the outer side of the watch glass so that the inner side is available for the reflection. Inner side of the watch glass is available for the reflection. In the second one, we are painting the inner side of the watch glass, so that the outer side of the watch glass is available for the reflection. Now, the first one is called as concave mirror. The first one is called as concave mirror, where the inner side of the mirror is reflecting. The second one is called as convex mirror. The second one is called as convex mirror, where the outer surface of the watch glass is reflecting. Now, what is the difference between concave mirror and convex mirror? So here we can have the diagrams of concave and convex. So it is the concave mirror. So these are the paraxial rays, and this is our principal axis. Paraxial rays means the parallel rays to the principal axis. The rays which are parallel to the principal axis are called as paraxial rays. When the paraxial rays are incident on the concave mirror, after reflection, they all meet at a common point, and that common point lies on a principal axis. When a paraxial rays are incident on a concave mirror, after reflection, they all meet at a common point, and that common point lies on the principal axis, and that common point is called as principal focus. That common point which lies on the principal axis is called as principal focus. The distance between the pole and the principal focus is termed as focal length, denoted by a small letter F. Now, what happens to the paraxial rays when they are incident on a convex mirror? So in case of concave mirror, the rays after reflection actually they are meeting. The rays after reflection actually they are meeting on a principal axis. But when you take an example of a convex mirror, this is our principal axis. Here is our pole. Here is our center of curvature. So the line joining the pole and the principal axis is called as principal axis. Now, when the paraxial rays are incident on a convex mirror, after reflection, they diverge from each other. They never meet each other at all. They diverge. But when you extrapolate the direction of the reflected ray, in the backward direction, their direction of reflection all meet at a common point. So the reflected rays appear as if they are diverging from a common point. Actually, they are not diverging from any common point. but their direction of reflection is in such a way that they appear as if they are diverging from a common point. So that apparent means which looks like, but actually it will not be there. So it is a apparent point where they appear as if they are diverging from that common point. So that common point lies on the principal axis, which is called as principal focus. The distance between the pole and the principal focus is denoted as focal length. The distance between pole and the principal focus is denoted as the focal length. So in case of concave mirror, here in case of convex mirror, the inner surface is coated or painted, the outer surface is available for the interaction of light. So in case of concave mirror, when the paraxial rays are incident on a mirror, after reflection they converge to a common point. So this mirror is also called as converging mirror. Now in case of convex mirror, when the paraxial rays are incident on a convex mirror, they appear as if they are diverging from a common point. So this mirror is also called as diverging mirror. Now the other two terms related to the spherical mirror are principal focus. So as you all have seen, what happens to the paraxial rays after reflection? The paraxial rays after reflection actually meet at a common point in case of a concave mirror, or appear to diverge from a common point in case of a convex mirror. Actually meet at a common point or appear to diverge from a common point on principal axis. That point is called as principal focus. The next point related to spherical surface is focal length. Now, as we have discussed, the distance between pole and the principal focus of the spherical mirror is called as focal length. So this is our today's discussion about the definition of optics, reflection, some important terms related to reflection such as incident ray, reflected ray, incident angle, reflected angle, how they are measured, laws of reflection, and how the spherical mirrors are formed. Why they are called spherical mirrors? Because they are derived from a sphere. They were the part of a sphere. So that is what they are called as spherical mirrors. So we have seen how the spherical mirrors are formed and some important terms related to the spherical mirror, and also types of a mirror, how the concave mirror behaves and how the convex mirror behaves. So in the next session we shall discuss with the image formation, how the mirror is going to form the image and what is the nature of the image formed by the mirrors.